Hello everyone, I am Dr. B.Sc Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. Today I am giving brief discussion on operational amplifier and its applications. So op-amp means operational amplifier. So operational, this comes op and amplifier M. So in together we are writing op-amp. So operational amplifier. So basic applications, those will be covered here for today's session. First one is inverting amplifier, op-amp as inverting amplifier. Number two, op-amp as non-inverting amplifier. Number three, voltage follower. Number four, a difference amplifier. Number five, adder. It is of two kinds: inverting adder, non-inverting adder. Few more applications are there, but will come later stage. Today we will discuss these things. So inverting amplifier, non-inverting amplifier, voltage follower, difference amplifier, adder circuit. So that is of two kinds: inverting, non-inverting. So first one is inverting amplifier. Let us draw the circuit diagram first. It's very simple circuit. This op-amp circuit. This is minus. This is inverting terminal. This is non-inverting terminal. So here this is input resistance. This is feedback resistors. This is output V0. This is RF. This is R1. And here we will use input voltage Vi. This terminal should be connected to the ground. So non-inverting terminal is connected to the ground. Now, what is the concept of virtual ground? This is most important. Virtual ground. Concept of virtual ground. So this is most important. What is that? We know that the input impedance of this operational amplifier is infinite. So current flowing through this path is 0. So this current is equal to 0. That means we can say in other words, the voltage difference between, if you say this is A, this is B, so VA minus VB, it must be 0. We know that if there is no potential difference, current must be 0. So in that case, VA is equal to VB. Now what is VB? This voltage is VB, this is VA. So VB is grounded. So that means VB is equal to 0. So VA is equal to 0. So this node is called virtual ground. So this is actually virtual ground. This is the virtual ground. Now, we'll make some current direction. So in this direction, this is input current I1. And let us consider this is the feedback current IF. So what should be the current I1? Current is flowing this path to this path. So that is I1. So higher voltage to lower voltage. So higher voltage is V1 minus this potential is 0 divided by R1. This resistance. So voltage by resistance is current as per Ohm's law. So now it will give you Vi by R1. So this is maybe number one expression. Now what is IF? IF current flowing this path, this direction, so higher to lower. So current, what should be the current component IF? IF should be this voltage is V0 minus this voltage is minus because this is ground. So V0 minus 0 divided by resistance, this is RF. So V0 by RF. So these two components are very important, IF and R. Now this is the node point, node A. This is node A. So the current in this direction I1, this is current in this direction IF. So both the currents are meeting at this point only. So as per KCL, summation over I is equal to 0. That means all the current components meeting at a point is 0. So here I1 is coming plus IF also coming. So that must be 0. So what is I1? V1, what is that? That is Vi by R1 plus what is IF? IF is nothing but V0 by RF. So that is equal to 0. So Vi by R1, that is equal to minus V0 by RF. So from that we can write the, what we have to find out? We have to find out the output voltage V0, that is minus RF by R1 into Vi. So this is a most important formula, the output voltage. So ultimately what we get is that output voltage V0 is equal to minus RF by R1 into Vi. So V0 by Vi, that is the gain for inverting amplifier minus RF by R1. Now the important thing is, the conclusion is that the output voltage is negative with respect to the input voltage. So there is a 180-degree phase shift between input and output. As the output is negative, this is negative. So as the output voltage is negative, so this is called inverting amplifier. So this is the circuit diagram for and corresponding calculations for output voltage inverting amplifier. Now we'll go for non-inverting amplifier. Non-inverting amplifier. First we draw the circuit diagram. First we will draw the circuit diagram. So always this configuration is, this is minus, this is plus, this one. So this is V0, this is RF, this is R1. In this case, this is grounded. And now here the input voltage is applied, that is Vi, because this is non-inverting. So input must be connected as non-inverting terminal. Now as per the virtual ground concept, this voltage and this voltage, that voltage and that voltage, this and that, these 2 point voltage must be same. So this point voltage is Vi. Okay. Now I am showing the current component. This one, this is IF and this is I1. So now here what should be the IF? IF is this current. So this voltage is V0 and this voltage is Vi. So current should be V0 minus this high voltage, this side high, because current direction is this direction, current flowing this direction. So high voltage to low voltage. So V0 is the highest voltage, Vi is the lowest voltage, by voltage difference divided by this resistance. What is that? RF. Now here what should be II? This voltage minus this voltage by R1. So this voltage is Vi and this is 0. So no need to write, it is grounded by R1. Now this current IF is coming inside this node and this current is coming out. So that means this is positive. If inside incoming is positive, so outgoing is negative. So IF is leaving, so minus I1, that should be 0 as per KCL. KCL at, if it is node A, so KCL at node A, what is that? IF minus I1 is equal to 0. So IF is equal to I1. So what is IF? IF is V0 minus V1 Vi by RF, that is equal to Vi by R1. Now from there, V0 by RF, we keep V0 by RF here. This Vi will go outside, right side, and if we take common, R1 by RF, that will come out. So now from this expression, so V0 by RF is equal to, what we get? Vi 1 by R1 plus 1 by RF, that we get. So now V0 is equal to Vi 1 plus RF by R1. So this is our output voltage. And now here both the symbols are same. This is positive, this is also positive. So that's why it is called non-inverting amplifier. Now V0 by Vi, that is gain. Gain is equal to 1 plus feedback resistor divided by R1. So later we stage, we will solve some numerical. So this is our non-inverting amplifier. Now we will discuss about voltage follower. What is that? Voltage follower. Number 3, voltage follower. We heard about emitter follower in transistor. So simply here voltage follower. It is basically showing gain is unity here. Gain is unity. This is the most important. There is no amplification. Now we'll draw the circuit first. We'll draw the circuit first. So this one op amp, this is minus, this is plus, this is, here we providing the input, suppose Vi, and here do something like that. Now this is 0. What we have done here? Here, this circuit. We made R1 RF short. RF short. So here, or R1 is equal to infinity. R1 infinity and RF is equal to 0. So in this expression, V0 is equal to Vi 1 plus, if RF is 0, 0 by R1, so it should be Vi. So ultimately what we get is that V0 is equal to Vi. So that means whatever the output, that is nothing but input. So in buffer circuit or emitter follower circuit, the output voltage is equal to the input voltage, but the gain is unity. So that means the gain is unity. So this is our voltage follower circuit. Now the purpose of using this voltage follower or potential follower or whatever, it is used as impedance matching. What is application? What is the application? The important application for this voltage follower circuit is impedance matching. impedance matching. Impedance matching. And this could be connected. So you people must remember voltage follower can be used as buffer. It's a buffer in between two stages. Can be used as buffer for impedance matching. For impedance matching, that is to connect a high impedance source to low impedance load. Suppose this is a system. This is connected to a low load. This is load, and this amplitude is low. And suppose source here, in this case, suppose is impedance. This side, impedance is high. In this situation, if we use this buffer circuit is op-amp circuit because we know that the maximum power transfer should be delivered to the load if the internal resistance is same with the load resistance. But in this case, this is very low, this is very high. So impedance is mismatched here. Now if we use this buffer circuit in between load and this source, then what will happen? For buffer or emitter follower or voltage follower, if we show in a box, so this impedance, that is the R0 in that case, and this is if it is input, we know that this op-amp, this impedance is infinity or large, but it is low. So for buffer circuit, it is having large input impedance and low output impedance or resistance. Now we have a source. Okay, it is having high impedance source impedance, and we are having one load that is low impedance. Now if we use buffer here, then what will happen? It is having high input impedance, but it is having very low output impedance. So this is input impedance is high, here its output impedance is high. So high with high matching, this low with low matching. So this is the low impedance for buffer. This is buffer or emitter follower. This is buffer. This is source. So source was connected to load directly earlier, and for that impedance mismatch happens. But if we use this load RL and this source in between in this buffer circuit, then this connections, this impedance match is fulfilled. There is no mismatch of impedance because high resistance with high connected, low with low connected. So that means impedance is fully matched. So that's why I wrote here, impedance matching is the most important application for this voltage follower circuit. So this is all about our voltage follower. Now third. Now fourth. Fourth is, what is fourth? We can check. Fourth is difference amplifier. So now we will discuss about difference amplifier. Difference amplifier. Difference amplifier. We will first draw the circuit diagram. Then we will go for discussions. So this is op-amp. Always we draw like this, minus plus. This input. This is RF. Always this is V0. This is RF. This is R1. This is V. Suppose this is V2. Now we are applying V1 here. Non-inverting terminal. One more resistance here. This is R2. This is R1. This voltage is V1. or we can say, for simplicity, we are considering this RF also R2. Now many methods are there to find out this output voltage. We can use different methods to get V0. So for simplest way, I am telling, so when we are finding out the V0, find V0 for input V2. Then what will happen? Make V1 is equal to 0 volt or grounded. Then what will happen? Simply we are making it grounded. So now it is completely behaves as a inverting amplifier. So in that case, what should be the output voltage? Minus, we know that, RF by R1 into VI, we know that. So based on that, what is RF? RF is here R2, so minus R2 by R1 is R1 itself into VI means V2. So that is the output voltage. So this is number one expression, V0, or we can say that for source V2. So now we can say that this is V02. We can say that V02 because for source 2. So V02. Now for V0 for voltage V1, then what we'll do? We make V2 is equal to 0 or grounded. Then what will happen? This is grounded. And what will happen? There is a power supply V1. Now this op-amp behaves as a non-inverting amplifier. It behaves as a non-inverting amplifier because this is grounded. Source is applied at non-inverting terminal. So now it behaves as a non-inverting terminal. Now we have to find out, we know that this voltage and this voltage are same for the virtual ground concept. So if it is V, if it is B, if it is A, so you have to find out VB. And VB is nothing but this voltage. This voltage also VB. So for non-inverting amplifier, what is the output voltage? We know that 1 plus RF by R1 into VB. VB means this voltage. So we have to find out VB here. So in that particular voltage, because we are finding out voltage for V1 like earlier, so now V01 we are telling 1 plus what is RF? RF is R2 by R1 into VB. We have to find out VB. So what is VB? So now see, I am showing the path here. This direction, this path. This current is 0. See, this is the closed path. So what is the voltage at VB? That is VB. How much voltage? So path is like this. What is the current? This current is nothing but V1 divided by R1 plus R2. This is the current flowing through this path. Now what is VB? VB is voltage across R2. So if this current is I, so this is I, and I into R2 is nothing but VB. as per the circuit. VB means the voltage across this resistor R2. So this current I flowing through the resistor R2, so that current, this I current into R2, if we multiply, that will be VB. And what is I? V1 by R1 plus R2. So what is VB? V1 by R1 plus R2 into R2. So VB is equal to, so here VB is equal to, I is how much? V1 divided by R1 plus R2 into R2 is there. So that is VB. So VB means R2 by R1 plus R2 into V1. R2 by R1 plus R2 into V1. That is VB. So VB is equal to R2 by R1 plus R2. See, R2 by R1 plus R2 into V1. Into V1. So that is VB. So we get VB. So now, what is V01? 1 plus R2 by R1 into VB means this one. R2 by R1 plus R2 into V1. So if you calculate this one, R1 plus R2 divided by R1, this will come out. And this is already R2 by R1 plus R2 into V1. So this one cancel out. This R1, this one, sorry. So R1 plus R2 and this R1 plus R2 cancel out. So ultimately what we get is that R2 by R1 into V1, that is V01. So we got V02. So output voltage V01 for input voltage V1 is V01. Now what is V01? R2 by R1 V1. R2 by R1 into V1. Now output voltage V02 for the input voltage V2 is V02 is equal to minus R2 by R1 into V2. See, minus R2 by R1 into V2. Now, what is V0? V0 is V01 plus V02. Just simply superposition theorem. Simple addition of these two voltages, linear addition. So R2 by R1 V1 minus R2 by R1 V2. So if you take R2 by R1 common, it will be minus V2. So V0 is equal to R2 by R1 V1 minus V2. So that is the output voltage for a difference amplifier. So R2 by R1, that is the gain actually here. What is gain? Gain is equal to R2 by R1. So that we have to remember for numericals. And if R2 is equal to R1, then V0 is equal to V1 minus V2. V1 minus V2. So this is also one more expression. So this is all about difference amplifier. Hope you people understand. So thing is that if you know the circuit diagram, then you will find easily the output waveform. Now we will go for 5, that is summing amplifier. So we will go for summing amplifier. First we will draw the circuit diagram. So circuit diagram of inverting ADAS circuit. Inverting ADAS circuit. So let us draw the circuit diagram first. Always this circuit is fixed. Minus, this is plus, this resistance, this is fixed. This is V0, this is RF, this is R1. Now the adder, so we have to use multiple resistance. So all together, this is connected. This is V1, V2, this is V3, R2, R3, and this non-inverting terminal is grounded. With resistor or directly we can ground. Now for the sake of simplicity, we'll consider one by one. Now this current, what is this current? This current is I1. Consider this is I2, this is I3. So what is I1? Because this point is 0, this is grounded potential, this point also 0 because of the virtual ground concept. So I1 is equal to V1 by R1. Similarly I2, this path I2, so V2 by R2. What is V3? Because this resistance is R3, so I3 is equal to V3 by R3. Now this together current, make a sum of this current I. So I is equal to I1 plus I2 plus I3. Then what will happen? V1 by R1 plus V2 by R2 plus V3 by R3. So this is the total current I. Now suppose this current, this feedback current IF. So what should be IF? IF should be this voltage minus this voltage. This voltage is how much? V0. This voltage is 0 because this point is 0. So 0 voltage, 0. So 0 minus 0. So no need to write minus 0. And the resistance is RF. So V0 by RF. Now this current coming this direction, this total current, and this current is coming this direction. So this I plus IF, because some current, this is some current I. So I plus, so as per KCL at this node, if it is A, so at node A, what will happen? So like this is node A, and this current is IF, this current is total current I, that is I1 plus I2 plus I3, that current. So coming this direction, this is this direction. So IF plus this current I should be equal to 0. So now IF is equal to V0 by RF plus I means I1 plus I2 plus I3, that is V1 by R1 plus V2 by R2 plus V3 by R3, that is equal to 0. So V0 by RF is equal to, if we take minus common, so V1 by R1 plus V2 by R2 plus V3 by R3. So that will come. So V0 is equal to, now what we will say, R1 is equal to R2 is equal to R3 is equal to R. If it is something like that, then what will happen? So here all will be R. So in that case, V0 by RF is equal to minus 1 by R, it will coming out. So V1 plus V2 plus V3. So now if you write V0, then RF will go this side. So now V0 is equal to, what will happen? Minus RF by R1. V1 plus V2 plus V3. So simply it's addition. So V1 plus V2 and V3, that means we are getting the addition of the input voltage. So that's why the name of the circuit is ADAS circuit. So, and this is the gain. So because of the inverting, so minus comes. Now again we may write RF is equal to R1 if both resistance are R. then simply V0 should be minus of V1 plus V2 plus V3. So that is our output voltage as inverting ADAS circuit. So it's a negative sign, so it's a inverting ADAS circuit. Inverting ADAS circuit. Inverting ADAS circuit. So now we have one more circuit, that is non-inverting summing amplifier. Non-inverting summing. So that will be discussed in the next class, next video. Till then, thank you.